Hi guys, I'm going to do the last half of the exam review that's there. And so when we're done with this should be all of the review. So for some reason you feel like you need to hear something again, you're welcome to go and go back and watch the video again. Also, almost all of these sections I've taught at some point in my class, although not this year because our schedule's so jacked up, but if you go to YouTube and you type in my last name of Hesslau, it'll be the only Hesslau channel that's on there. So if you go in and look, you might be able to find some other videos as well. So I'm going to go through and do these. I am going to kind of create a little room for myself on here as we do this, just to give us some room to write. And then I'll kind of erase a little bit as we go, I think. It's about the only way we can kind of make room. So on this first one, it says, what is the solution of the equation? And you have the square root of x plus 10 minus 7 equals negative 5. So remember, when you're solving any of these, they have square roots. The whole idea is to get the square root by itself. So if I start with this, my first piece would be to get rid of this subtracting 7 to get this alone. So the opposite of subtracting 7 is adding 7. So I'm left with the square root of x plus 10 equals 2. And then to get rid of the square root, I would have to square both sides. So that would give me x plus 10, because the square root and the squaring cancel each other out. Equals 4. And then I'm going to subtract 10. So I get x equals negative 6. So that would match D. Okay, now remember, you're going step by step to solve these, so I can see your work. You can do it on line paper in your notebook or whatever, but you are taking pictures again at the end to submit for this review, and you'll do the same thing on your exam. Okay, let me go to the next one here. See if I can make myself a little room. Okay, and this one, same thing. I'm going to try to get the square root by itself. So my first piece is going to be to get rid of this negative 10. So the opposite of negative 10 is positive 10. So I'm going to add 10 to both sides. So the square root of x plus 8 equals 6. And then again, we're going to square both sides. So I have x plus 8 equals 36. And then my last thing to get x alone would be to subtract 8. So I get x is 28. So the answer would be B. Okay, let's go to the graphing ones. Okay, so this one says graph the exponential function y equals 4x, 4 to the x, and then you have these 3 graphs there. So first of all, this is definitely a Desmos problem. So I'm going to take and put this equation into Desmos and basically see which one of these graphs it matches. So let me grab Desmos. So I have y equals 4 to the x. So remember, a lot of times in being able to help us on graphs, it helps us to be able to have, I don't know, a couple of points that you can pretty easily tell what they are. So I can see right there that is 0, 1. I can hold my finger down if I want and try to find another point. So I have one at 1, 4 as well. So those would be 2 points that would be helpful for me when I'm going to look at this. So if I have 0, 1, and 1, 4. Probably the only one that's even close to that would be D. So the graph happens to count by 2s, so that would be your 0, 1 going up, because you can see if 4 is here, this had to be 2. Let's see, 1, 4 would be there. So you know those 2 points are on there. So that would be D. Again, get a couple points when you're graphing in order to ensure you've got the right thing going on. Okay, here's our next one. Okay, again, I'm just going to make a little room for myself for right now so I can do the equation part. This says the initial population of 820 quail increases at an annual rate of 23%. Write an exponential function to model the quail population, and what will the population be after 3 years? So first of all, if we're doing an exponential model looks like this. Now, this is usually your beginning amount, and this is usually a percentage. So we know in this particular problem that our beginning amount is 820. So we know this has to go at the beginning. Now, to get this percentage, we have to think about what we have. So this says that this percent increases by 23%. So if you already have 100%, it goes up by 23%. It's now going to be 123%. But when we usually do this percentage here, down here, it's usually in the decimal form. So if it's 123%, remember a decimal usually starts there, but as a decimal, it has to go over 2 places to the right. So as a decimal, it's 1.23. So that's going to go here. Okay, so based on what we have, this doesn't match, this one doesn't match, and this one doesn't match. So I'm thinking the answer is going to be A. I only have one more thing to do. I need to check what the population is going to be after 3 years. So after 3 years, I would take the X out, and I would put a 3 in its spot. Okay, so let's see what this will be if we put this part into decimals. Now, I will tell you, this is a whole number. So if I get a decimal, which could happen, I've got to be careful of that. So in decimals, I'm going to do 820 parentheses 1.23 raised to the third. So you can see my number that's there. I do have a decimal, but the nearest whole number would be 1,526 if I rounded that. So those 2 pieces are really your answer. So it does match A. Okay, now remember, as we're going, if you need to pause for any reason so you can write something down, do that. I know I'm kind of erasing as I go, giving myself a little room, but I want to make sure that you're paying attention to that. Okay, so here's my next one. The next one says graph the function, and I have y equals -2, parentheses 1 over 8, parentheses raised to the x. So I want to see which one of these graphs that's going to match. So this right here is going to go into Desmos. So in Desmos, I have y equals -2, parentheses. Remember to do 1/8. You got to do 1 divided by 8 to get the parenthesis. or to get the fraction. Then move over and do your parenthesis, raised to the x. Now this one looks different because you can see it's definitely underneath the x-axis, which happens anytime the number in front is a negative number. We have -2. If I look, I can see it hits at 0, -2. And then if I look, it's really kind of hard to find one that's going to be exactly on the line. So we know it's going to kind of go up and get close to the x-axis on, the right-hand side. So let's see what choices we have. Well, geez, we don't have much choice. The only one that's really opening in that way is A, because you can see how it's kind of down here. Okay, again, screenshot that, move on. Okay, here's our next one. So y equals 5, parentheses 1/4 raised to the x, plus 2. Now we're going to see which graph that it matches. Okay, so I'm going to take this again and put it into Desmos. Okay, so let's back up here. So y equals 5, parentheses 1/4, raised to the x, plus 2. Make sure that plus 2 is on the end and not with the exponent. I was able to use my arrow keys underneath this function word. So right where it says functions, I used my right arrow key to move over. So I got back down on the line. So just kind of pay attention to that. Okay, it looks like the y-intercept is at 0, 7. Okay, this one isn't perfect, but right around 3, 2 is another point. So if I go back and look at the graphs, geez, the only one hits close to 0, 7 is this one. So right around 2, 3 something, or 3, 2, you're going to see a point. So you can tell the only one it's going to match then is D. Okay, a couple more graphing ones, and then we're going to go to kind of solving again. This one says sketch the asymptotes and graph the function. So first of all, there's a couple things. I want to be able to use this in Desmos for sure to see which one it matches. But notice on all of the graphs that I have, they have those dashed lines for the asymptotes. So you're going to have to be able to know how to get those to show up on Desmos. So I want to make sure we'll pick the graph that matches first, and then we'll talk about how to get those asymptote lines on there. So I'm going to start by going and graphing this first in Desmos. Okay, so I have y equals 4 divided by, oops, I guess it's got to be -4 there. So -4 divided by, now move the negative in front, and as long as the negative's there, I really don't care where it is, as long as it's out in front. So I did this part. I'm going to use my arrow key to the right, so I get on the end, and then I'm going to do -3. So you can definitely see that you have your piece there where it's graphed. I also can see that there's probably going to be some asymptote lines. But they're not on here yet. So first of all, let's go and look at which graph this matches. Okay, so if I go back and look at this, find the one that matches that. First of all, the only one that's even close is right here at C. Because of where the graph is at, it went below the x-axis, kind of on this side. You'll notice there's one of the asymptotes runs up and down, hits at -2. So if it runs up and down, it's x equals. So I'm going to add x equals -2. That black line that I just made right there is my asymptote. And you can see it doesn't hit the graph. It just gets close but never touches kind of thing. Okay, let's go back and get the other one. So the other one hits at -3, and it travels the same way as the x-axis, which means it's a y equals line. So y equals -3. And there's your other asymptote. So once you get both of those on there, this is when you can take a screenshot and have that be done. Okay? Okay. This one says this graph of the function is a translation of y equals 4 over x. What is the equation for this function? So first of all, you're going to see with all of these that they all have 4 in the top of the fraction, x in the bottom. That's what it means. Talks about translation. I think the easiest part, though, to look at with these is just to see what this graph would look like to begin with. So let me stick that into Desmos. So I'm going to go back here and take all this crap out and put in the parent function they're talking about, which is this. So you can see this is kind of centered around the x and y axis. And actually, the asymptote lines would be the x and the y axis. They kind of keep the graphs kind of in their boundary. Now, if you look at this one, you can tell it's not focused right there. It's been moved. So let's see. It's gone up 3. That means there has to be a +3 on the end of your equation. So you know you're going to have something with this. But if it goes up, it's got to be +3 on the end. Okay, that's a good piece to look at. It also looks like this got moved over 4. But whenever we've talked about getting moved over 4, it's always based in the idea that there should be a minus down here. And then if it gets moved over that way, it's like a -4. So remember, 2 negatives make a positive. So it should be y equals 4 over x plus 4 plus 3. And that would match D. Now, what you can do as well is you could put each one of these separately, one at a time, into Desmos, and you could see which one's going to match this graph. That's okay, too, as long as I can see that it actually matches, including the asymptote lines. So the little dash lines, remember how we put those in on the last one? You would have to do that as well. So this one would be like x equals -4. And this one would be y equals 3. So just keep that in mind. Okay. On 34, it says, what is the quotient in simplified form and state any restrictions? So don't forget this part when we get done. But probably the easiest way to start this is that it looks like this, and this are all in simplified form. It would really help us if this were factored. So the first thing I'm going to do is deal with that. So a plus 2, a minus 5 are going to come in. I know on the top it's going to be a minus 1. The bottom factors to a minus 3 and a minus 5. So in order to be able to deal with this, first thing you have to do is get it in that form. Okay, then remember, whenever you divide a fraction, the first fraction stays the same. Division changes to multiplication. I flip the second one. Now, if I do that, there's kind of a couple things that I need to pay attention to. We can cross cancel like we can with fractions. So if I cross cancel, a minus 5 happens in the top and the bottom. That's the only one that does that. So I'm left with a plus 2, a minus 3 over a, oh, I guess I probably should make it plus 1. Sorry, guys. It was a plus over here. That was my error. A plus 1. There we go. Okay, so if I'm looking at just that part, there's no way it can't be B. It can't be D. So at least the fraction part matches on both A and C. So let's talk about the restrictions. The restrictions happen with anything that could be on the bottom of a fraction. So I'm going to go through and look for unique things on the bottom at any point during the problem. So I can see a minus 5 was in the bottom. A minus 3 was in the bottom. I already have a minus 5, so we're good. A minus 5 we already have. Oops. A plus 1 is different. And then a plus 1 down here. So I have 3 things in the bottom. Now remember, it's thinking about what those would have to be to get a 0 in the bottom for that spot. So in this one, if a were 5, 5 minus 5 would be 0. So that means that there's no way a can't be 5. For this one, if I put a 3 in for a, 3 minus 3 would be 0. So again, a can't be 3. In this one, to get 0, a would have to be negative 1, because negative 1 plus 1 would give me 0. So a can't be negative 1. Those would be considered to be the restrictions. Okay, and the only one that would match all of those would be A, because you can see on this group that 5 is left off. So that would be A. Okay, next one, identify the sum. Now, if I look at this, I can tell right now there's nothing to factor here, but I got a whole lot I could factor in those two. So before we do anything, let's factor them. So I know the second fraction's not going to change, but the first one will. So the top of that, this a squared plus 7a plus 10 would factor into a plus 5 and a plus 2. This one down here, so a squared plus 2a minus 15 would factor into a plus 5 and a minus 3. So if you look at that, these two pieces match and we can cancel them. So I'm left with this plus this. Now they have the same denominator. So I can take and put all of the top together over this. Now, this part I could put together. So positive 2 and positive 10 is positive 12. So it'd be a plus 12 over a minus 3. So that would match A. Okay, let's go to 35. Simplify the difference. So again, we're going to have to somehow get common denominators, but I can certainly tell these two would be things that I could go through and factor. So let's do that. I'm just going to write down my problem. Second part's good to go. It doesn't have any parts that can factor. But if I look in this first part, I'm going to do the top first, so this part. So n squared minus 10n plus 24. So that's going to be n minus 6 and n minus 4. On the bottom, if I start to factor this one now, it's going to be n minus 6 and n minus 7. So I can see again how these are going to cancel. So I'm left with n minus 4, n minus 7 is 9 over n minus 7. Oops, sorry about that. So they both have the same common denominator, so I can move them all in to the same fraction. Okay, so this part right here I can put together. So negative 4 and negative 9 is negative 13 and minus 7. So it's going to match A. Okay. Now, the next part, we're going to start to get things into exponential form. So with logs, remember to do exponential form, this is your base. This is going to be 4. That becomes your exponent. And after the equals goes this part. So on this one, that's going to match D. Okay, not much work for that, just moving stuff around. So that'll be one of the few that that's kind of true for. Okay, now this one says evaluate the log. So you have a couple, I guess, things that you could do. One is I can put this exactly the way it is, put it into Desmos, and be able to solve it. So let me show you what I mean. In Desmos, in that function key, there's lots of additional pieces that are there. If you go to miscellaneous, you'll see logs there, but there's 2 logs. So the log in the first column is when it has a base of 10. This other log in the second column is when it's at the base 10. So this wasn't the base 10. So it's log base 3 of 243. And it'll give you 5. So just take a screenshot, go on your way. Okay, now you could go through and solve that, but here's the thing I would suggest. Some of these problems are going to take you longer than others. Don't make them take longer. Okay, just do the best that you can to get through them. Okay, this one says write the expression as a single logarithm. So I'm going to have to go through and use the properties of logs to put things together. So first of all, these both have numbers out in front, so I'm going to have to put these back where they go. So this 3 would have been an exponent for the Q, and 6 would have been an exponent for the V. So this should have been log base B of Q to the 3rd plus log base B of V to the 6th. Then, if these are put together with an add, that means that these 2 pieces must originally have been multiplied. So it's going to be log base B of Q to the 3rd, V to the 6th. And then we actually sit them right next to each other so it looks like multiplication. Okay, so on this one, it would match A. Okay, now on 40, you have log of base 7 of 50 minus log base 7 of 5. So there's no numbers in front to consider at all, but if there's minus, that means those 2 pieces must have been divided. So that means that it's going to be log base 7. First number goes on top. Instead of subtraction is division symbol. Then the second number is going to go on the bottom. So we know we can actually take 50 and divide it by 5. And get 10. So on this one, that's going to match C. So that's when you take a bigger one and put it together. If they want us to take them and expand the log expression, that means we're going to do the backwards. So if this is division, you can separate them with a subtraction. So log base 3, the piece on top is D, so that goes first, then minus, then do log base 3 again, and then the number in the bottom, which would be 12. So this one matches A. Okay, in the next one, this whole thing is multiplied. Now, I know there's an exponent there. I can't deal with the exponent until I get these in two separate ones. So it's 11 times p to the third. So if it's multiplied, I can put them together with an addition. So log base 3 of 11 plus log base 3 of p to the third. So you have to get it separated before you can take that off and put it in the front. So the 3 is going to go in front of just that log. So it's log base 3 of 11 plus 3 times log base 3 of p. So on that one, that matches C. Okay, remember, take the exponent off, though, if you are expanding it as much as you can. Okay, 43. Use the change of base formula to evaluate log base 7 of 40. So if you want to do the change of base, you do the 40 on the top, take the base off. So now it becomes a base of 10. And you're going to take it and do log over whatever the base is, which on this one would be 7. Now, I would take this whole part right here, and at that point then, I would put it into Desmos. So in Desmos, let me get rid of this. When I go to functions, I'm going to choose the regular log this time. So log of 40 over the log of 7. And you can see there you get your 1.8957, yada, yada, yada. So if I go back, it would match that one. Okay. So now we're going to go through some of these that are going to ask us to solve. And again, I'm going to do the same thing I did before. I'm going to try to make a little room for myself to solve, and then I'll get rid of this crap later on and erase it to go to the next problem. Okay, I have 4 with 4 to the x equals 8. Now, I know if I look at 4 and if I look at 8, it would be really helpful if those numbers had similar bases because it would help me. And I know that, that I can rewrite 4 as 2 to the second. Okay, then I'm just going to add this 4x to the top up there. Now, I also know 8 can be written as an exponent of 2, so that's 2 to the third. So it's really helped me now because I have matching bases. So when I have these bases being matching, that means these two pieces have to be equal to each other. So first of all, 2 times 4 would be 8. And to get x alone, I would divide by 8. So I have x equals 3/8. So in this case, it's going to match C. So again, if you have matching bases, then you can use that exponential idea to get solving. But then you have to be able to know, okay, if these bases don't match, do they have something in common? Okay. So let's see. I'm going to go to the next one. Again, I'm just going to make myself a little room here. You can do this on separate paper, so you have a little bit of an advantage. I don't, I guess. So, okay. So this one says solve 15, 2 to the x equals 36, and round to the nearest 10,000. So we got to remember that spot when we get done. So first of all, if I start out with this, I know as I'm trying to solve these, being able to get exponents off or being able to get them kind of set up would be very helpful to us. So I look at 15 and I look at 36 and think, man, I'm not sure that I can think of anything that they have in common. So we're going to have to kind of think about how to be able to get those to kind of match. So I want to know what I can put in, for this x value up here that would give me 36. So you have a couple choices. If you're trying to solve that, that definitely gives us a chance to being able to plug stuff in to kind of know that. So first of all, I know that it might actually help me with the log version of this. So I'm going to give you kind of a minute here. So in this one, my base, in this one, my base is 15. So I'm going to do log base 15 of 36 equals 2x. So I know to get x by itself, I would have to divide by 2. So basically I have this. Now at this point, I would take this whole part and I would put it in Desmos. So let's go to Desmos and put it in. So in this one, let's see, I have a log. Remember, that was a base of 15, so it wasn't base 10, so I'm going to choose this one. So base of 15 of 36, close my parenthesis, do divided by 2. So I have 0.6616, yada, yada, yada. So that means on this one, it's going to match A. Okay. Now remember, if you're using Desmos, I'm completely okay with that. If you go through your solving and then you're just using the last part of it to put in, that's completely good. Okay, let's go to this next one. Okay, again, I'm just making a little room for myself here in my 5th grade handwriting. Okay, so this one says solve the log equation, round to the nearest 10,000th if necessary. So I have 3 log of 2x equals 4. So there's kind of a couple things that I can do. First of all, I'm probably going to want to take this 3 and use my property to put it on as an exponent of that. So log of 2x to the 3rd equals 4. Now, probably the easiest thing to do right now would be just to take this and cube it. So 2 cubed would be 8. X and then x cubed equals 4. Now do remember, if they don't give you a base, that means you have to assume it's 10. So now we're going to change from being a log to being an exponent to solve it. So it's going to be 10 to the 4th equals 8x to the 3rd. So if I have, let's see, 10 to the 4th, 10,000. Okay, divide both sides by 8. Now, just for a second, I'm going to be lazy and not divide it till I go to my calculator, just because I know in this I can kind of help myself out a little bit. If you have a 3rd here, to get it off, you'd have to do a cube root. So really, it's going to be this. So I can actually take this whole part and put it into Desmos all at once. Now, if you want to solve this little piece right here, and I think it's 1250, you can do that, but I kind of like just to wait to the end. So if I go back to Desmos again, if you go back to this function stuff, I want you to look at the second column right above the log when we're using, do you see how it's n to the square root is what it looks like? So when you get that, you can choose what the root is. So I'm going to do the third root. Then I'm going to move underneath and do 10,000 over 8. And it'll actually do the whole thing. Now here's the thing. If you divided it out and got that it was, I don't know, 1250, notice that you're getting the same answer. So I just want you to feel like you can do it either way. Okay, so if I go back here and look, it's going to match A. Okay. Okay, let me get rid of this crap so I can make a little room again. Okay. Good news is we're getting towards the end. I think there's 51 or close to that. Yep, there's 51. Okay, so on this one, it says solve this, and you have log, parentheses, 4x plus 10 equals 3. So remember when you do this, if they don't give you a base, it is 10. So let's go ahead and get it in exponential form. So it'd be 10 to the third equals 4x plus 10. Because remember, you go, this is the base, that's the exponent, equals this. So 10 to the third is 1,000. And now we just need to solve for x. So subtract 10. Okay, let me move this up here just so I have room to write. Oops. Nothing like changing my numbers there. Okay. And then I'm going to divide by 4. Oops. And I would take this part and put it into Desmos. So before we do, will you just look at the answers? So you either have the possibility of having 2 fractions up here or 2 whole numbers. So I might actually put that in as a fraction into Desmos and see what happens. Either it'll give us a whole number or it'll give us a fraction, one or the other. So 990 divided by 4. Now, if you don't remember this, it gives you a decimal here, but do you notice in this problem how once you put it in fraction form, it gave you a little circle in that blue area in the front with a fraction? So if you hit that, it will change it to a fraction for you. That means there's a fraction form that's equivalent to that. Okay, so it matches B. Okay. Let's go to the next one. The next set of directions says write the expression as a single natural log. So remember, these have the same properties as regular logs do. So write it as a single log. I'm going to take this and put it as the exponent here, and this and put it as the exponent here. So it's the natural log of 3 to the third plus the natural log of c to the third. Now, I know this 3 to the third is 27. So you really have this. Okay, then remember, if it's a plus sign, that means these two must have been multiplied. So it's the natural log of 27 c to the third. So that matches this. Okay. Now, next one's going to take me a little room. I'm going to make myself a little room here. So this one says simplify the natural log of e to the third. So let's see if you remember this. So natural log is the same as the log of e. So these, it would actually go and look like this if you replaced it. So the natural log is the same as this part right here. Now, here's kind of the cool thing. When you get this line up where you have the log of base E of this base E to the third, these all cancel each other out. So you're just going to be left with 3. So the answer is going to be A. So if you don't remember that part, that is kind of a little piece that we use to solve. Just got to go back and review that a little bit. Okay. Almost done, guys. This and one more. Okay, this one says solve the natural log of 2x minus 1 equals 8, round to the nearest 10,000. Okay, so first of all, if I have natural log of this, remember, we're going to use the same thing we just did. I'm going to take this out and make it log base E so I can do some solving. So let's change it to an exponent. So E to the 8th equals 2x minus 1. And then we're just going to work to get x alone. So add 1. And then divide by 2. So I have x equals e to the 8th plus 1 over 2. Okay, so I'm going to go through right now, and your choice is to put this whole part into Desmos. So hang on, I'm just going through to... I'm going to put it in my calculator so you can see it. So I'm going to go through and put this, oh, I guess I can put it on my iPad. I'm going to put this part right here into Desmos. Okay, so in Desmos, on the top of that, I'm going to do parentheses because I'm going to have a fraction, but more than one thing on the top. So if you look at all of these, you don't see the letter E, but there's an ABC button that's in the bottom corner. If you hit that, then you can see your E is there. Then I'm just going to hit 1, 2, 3 to go back to my other screen. So E to the 8th, I'm going to move to the right, plus 1, and close your parentheses. Hit your divided by, and put your 2 on the bottom, and I get 1490, yada, yada, yada. Or 1,490. So on this one, it's going to match D. Oops. Okay. Last one. I'm sure you're as excited as I am. Okay, the next one says use natural logs to solve the equation and rewrite, and to round to the nearest 10th when you're done. Okay, so first of all, to be able to do this, I really want to be able to get the E alone before I can actually use the natural log. So let's work to get E alone. So I'm going to add 2. Then I'm going to divide by 6. And I'm just going to leave this as a fraction for right now. I'm going to be a little lazy about it. Now, once you get this part done, now I can do the log of both sides. But my base here is E, so watch what I'm going to do. I'm going to do log base E of e to the 4x. Hang on, I guess maybe I'm going to move it down just a little bit. Wrote a little close there. E to the 4x. And I'm going to do log base E of 5/6. Now the reason I'm doing that is because this will all cancel. And I have 4x log base E of 5/6 here. Now remember, this is the same thing as the natural log. So at this point, if you want to change it, you can. Kind of needed to have the log base E here just to get this part to cancel. Okay, divide by 4. So I have x equals the natural log of 5/6 divided by 4. So now this part we're going to put into Desmos to get our answer. Okay, so if I go back here, in the functions part where we were, the natural log is in there. It's in the first column above the log. So I'm going to do the natural log, 5 divided by 6 in my parenthesis. Oops. And then I'm going to divide it by 4. So I get this negative 0.045, yada, yada, yada. So if I go back to my answers, it's going to match D. Okay, again, go through all of the review stuff. If there's stuff you're still stuck on, that's definitely stuff to get in contact with me so we can make sure we go over it. Okay? And make sure, again, you can watch the video more than once. Do what you need to do to help yourself. Okay, good luck, guys.